Okay, good morning, everyone. Can you hear my voice?
Yes, sir.
Okay. Everyone, please give your attendance. Okay. Okay. Let me start my class. In our previous class, we already discussed about how to find out the residue of a complex function. Okay. If it is simple full, we can find the residues of a function by using a formula, and also when it is a double pole or higher pole, we have to use the derivative formula for find out the residues of our complex function. Okay, so today I will discuss about a theorem which is theorem. Okay, this is Cauchy residue theorem. Okay, so তোমরা অনেকেই হয়তো বা কচি রেসিডিউ and also কচি রেইমেন এই ইকুয়েশন গুলো এই থিওরেম গুলো এক করে ফেলো তো কচি রেসিডিউ and also কচি রেইমেন, these two are different things, so please don't do that. Here for Cauchy residue theorem, we know about residues, so just let me study. Everything. So this is our statement for Cauchy residue theorem. Okay, so at first I said that all of you please give your attendance at first. Okay. Uh, Here the statement is if Fz is analytic inside and on a simple closed curve C, except at a point at a finite number of points A, B, and also C inside C, the simple closed curve C, at which the residues are A subscript -1, B subscript -1, comma, and also C subscript of -1. Here C is also a small c, and this is a capital C. So this one is a simple closed curve, and also this one is a point. Okay. So respectively, then we can say closed integration fz dz equals to 2 pi I into a minus 1 plus b subscript of -1 and also c subscript of -1 plus dot dot dot, which means this is 2 pi I into sum of the residues. Okay, so this is a statement. Here, all of you know that a minus 1 is, we can find, this is the residue formula, and we can find it from Lorentz extension. Now I have to prove this. To this just take a look here. See, so those are capital C. This is our simple closed curve, and also there's some circles where the points are given, so which is A, B, and also C. And these are the curves which are declared by C1, C2, and also C3. Okay. Now, so this theorem, let us consider uh, C1, C2, with center which lie entirely within C. Okay. Or then we can say that. Do you remember about Lorentz extension? Anyone? Do you remember about Lorentz extension or Lorentz series? খেয়াল আছে তোমাদের গত ক্লাসে যে করিয়েছিলাম? Okay, I just say this. Okay.
স্যার এটাই কি প্রথম প্রুফ ক্লাসের, মানে একটু পরে জয়েন করলাম তো?
Yes, yes. So I just give the, I have already given the statement of Cauchy residue theorem. Now I have just proved it. Here, all of you know that the Lorentz extension, about the Lorentz extension. So we have to use this extension in here. From Lorentz extension, we know that if fz is analytic by symbol. Since if it is analytic inside and on simple closed class C x z equals to A. So by two, so the Lorentz series you can say আমাদের এক্সটেনশনটা কি ছিল কেউ একজন বলো তো for Lorentz series tell me. Okay, that's there we use for residue theorem A minus equals to what? We know that this is means 2 pi I division of C that means fz dz. Okay. Uh, we know about Lorentz extension, which is fz equals to summation of a subscript n z minus z to the power z not to the power n. Okay, and also or আমি এখানে z minus z not বলেছি here we will use z minus a to the power n. Okay, and where n equals to 0 above up to infinity, and also plus summation n equals to 1 in, up to infinity fz যেটা ছিল হচ্ছে তোমাদের a minus n subscript minus n z minus a to the power minus n ছিল ওকে আর তো সেই ক্ষেত্রে আমরা জাস্ট ও আমরা কি জানতাম সেখানে আমাদের রেসিডিউস বের করার জন্য একটা ছিল ইন্টিগ্রেশন বাট আমরা এটাকে আবার লিমিটে কনভার্ট করে শিখেছি কিভাবে লিমিটের ফর্মুলাটা ইউজ করতে হয় so here a minus subscript minus 1 equals to can be written as 1 by 2 pi I so close integration fz dz. So by using this thing you can say if a that can be written as c1. Okay, for the point A. Okay. Now for b minus 1, you can also write it that 2 pi I into division c2 fz dz. And after that also c minus 1, you can write 1 by 2 pi I into division c3 also fz dz. After that, you can easily say that also okay. Now you can say that the whole curve, simple closed curve C. Okay, here C1, C2, and C3 I say, but for whole curve you can say integration C f z dz equals to, you can write it like that 2 pi I into a minus 1. এটাকে এইভাবে লেখা যায় okay. If I say C1 fz dz plus integration C2 also fz dz, and also you can say C3 fz dz plus x. Now just take a look here. You can also write these things in this way, which is a closed integration where C1 fz dz can be written as 2 pi I a subscript minus 1. So you can easily say that it means 2 pi I a minus 1 plus 2 pi I into this is means b minus 1 and also 2 pi I c minus 1. Okay. Everyone please mute yourself. Okay. So here you can also say that 2 pi I a minus 1 plus b minus 1 and also c minus 1, which means the sum of the residues. These are the residues. So you can easily say this is the sum of the residues. Okay. So hence we proved our theorem, which is our Cauchy residue theorem. Now I will give you an example on it, which tell me about those things. Okay. Hence our theorem. Now, show that so the integration e to the power tz divided by z square plus 1 whole square dz equals to pi I sin t minus t cos t, where c is the circle z and also t is 0. Okay, so here our given example is show that the simple closed curve integration of c e to the power tz divided by z square plus 1 whole square dz equals to pi I sin t minus t cos t, where c is the circle, z modulus of z equals to 3 and t greater than 0. So you have to use the Cauchy residue theorem. You can also solve this problem by using Cauchy residue theorem. Okay, so let me say at first what we have to do for find out this residue theorem or find out the residues.
C1 C2 C3 তে ভাগ করে নিব স্যার।
বুঝিনি, আবার বলো। Okay, the formula is what about the residue formula? Please tell me the residues formula. A inverse হলে কি হবে if it is a simple code?
Z minus A into f of z. Limit z if z tends to a. Z minus A into f of z.
And if it is double code, তাহলে কি হবে? Double or higher code of order n. Then what is the formula for residues? Find out the residues. Where so factorial m minus 1 d by dz. That means m minus 1 also m minus 1, and then what you have to use? Bolo z minus a to the power n x z. So this is for double code. Okay, and this is for single code formula for find out the residues. Okay, so you have to What is our Cauchy residues formula? Our Cauchy residues formula is this, which is mz dz equals to 2 pi I, and also sum of the residues. That means those things, okay, for different points. The sum of the residues. So you have to find out the residues of this problem at first. Okay. So for find out the residues, so what we have to do from here? কি করতে হবে বলো? Here we can let fz is e to the power tz divided by z square plus 1 whole square. Okay. Now এখন কি করবো বলো? You have to find out the residues. Okay. So for find out the residues, what we have to do at first?
Denominator equal to 0 করতে হবে।
Yes. So this is the simple answer. You have to let denominator equals to 0. So if z square plus 1 whole square equals to 0, we can say this can be z square minus I whole square equals to 0 and also square. And from here, you can also say that this is z square. Also, that can be written as plus minus I. That means you can find I and minus I. Okay, from here. So you can say, is it double pole or single pole? Simple pole.
Double sir.
Yeah, double pole, because we can find I and also we can find minus I and also minus I, because whole square chilo এবং পরে আরেকটা whole square chilo. Okay, so from here you can say this z is a double pole for I and minus I. Okay, so you can say that both of double pole, and also lie. You have to check this if it is lie inside the circle or not. See, cos what? Cos you can say this is I equals to 1 is 3. Okay. So also minus I equals to 1 is 3. Okay. So this satisfies the condition which is lie inside the circle. So you can say you can put this here. Now just take a look here. You have to find out the residues of this problem. Since it is a double pole, so you can say residue of z equals to I E. So what is our formula? Just tell me. Limit z tends to I. Then এরপর কি করবো বলো? For z equals to I, this we can find the double pole for this function. So what should we do? Which formula we have to learn?
Higher order formula ফেলতে হবে স্যার, মানে
Higher order, that means derivative formula. So what is the formula?
1 by factorial n minus 1.
So m minus 1. Here m is equal to, what is the value of m?
2 sir.
2, because we get z equals to I. This is a double pole, so that's why you can say this is 2 minus 1. Okay, then d to the power 2 minus 1 divided by dz to the power 2 minus 1 and also you can say z minus I to the power 2 into fz. So our fz is this. So easily you can solve this problem. So you can write things in here, which is z tends to I, and this means 1, and also we have to take d by dz, also dz minus I whole square into e to the power tz, and also z square plus 1 whole square. Similarly, we can say this thing, which is limit z tends to I, also d by dz, here z minus I whole square is to the power tz divided by, it can be written as z minus I and also z plus I whole square. So you can remove these things from here, and you can also write this thing in this way, which is d by dz and also e to the power tz divided by z plus I whole square. And after that, just apply u by v method derivative formula for u by v. Okay, then you can get, I just simplify this equation, and also if sometimes you can find the result, which is limit z tends to I, and also this is z plus I. Okay, and also here t to the power tz minus 2 e to the power tz. And after that, here z plus I to the power 4. Okay, and then you can say after put z tends to I, in here you can get 2I plus e to the power it and minus 2 e to the power it. Okay, divided by this, that means 8I cube. Okay, now after that, just simplify this equation. You can get minus t plus 1 e to the power it divided by 4. Okay, so this is the result for z equals to I. Okay, so this is the residues for z equals to I. If I say find out the residues for z equals to minus I, then what will be our result? Anyone? Do you
zero
have
is
any
or
idea?
sir.
হ্যাঁ বলো again বলো।
Z is equals to sir minus I না Z tends
Yeah,
to
for z equals to minus I এর জন্য কি হবে রেজাল্টটা? This is z equals to I, the residues for z equals to I. But if I say find out the residues for z equals to minus I, then what will be the result? Similarly, you have to follow that formula, that means derivative formula, and after that solve this thing, and you can get the result, which is t here, just look here plus I, and also here it. Okay, you just uh, change the sign of this conjugate number, which is a complex number. So এই I এর আগে just সাইনটা চেঞ্জ হয়ে যাবে, ঠিক আছে? That means that it will change in minus I, and also this is minus it. So this is the result for z equals to minus I. Okay, that is z tends to minus I, derivative formula usefully you can get the result, which is minus t minus I divided by 4 e to the power minus I. Okay, এটা similarly লিখে তোমরা এভাবেও দেখিয়ে দিতে পারো. Okay, you can show these things. Now the by Cauchy residues here, you can say e to the power t z square 1 whole square tz equals to, that means this is our 2 pi I, also sum of the residues. Okay, residues. So we already found that some of the residues here, one of them is minus t plus I e to the power it divided by 4. Also minus here t minus I e to the power minus it divided by 4. Okay, so just put those things in here. দুইটা আমরা ইয়ে পেয়েছি k minus 1 and also তোমার b minus 1. So যদি দুইটা পয়েন্ট ডিক্লেয়ার করি তাহলে some of the residues will be one point and for another point residues. Okay, so from here you can also simplify these things in this way. Just multiply those things e to the power it with these things and also e to the power minus it with these things, and after that just take common from these two things, which is t e to the power it plus e to the power minus it divided by 4, and also I by 4. Here we can say e to the power it minus e to the power minus it. Okay, just multiply this thing with this equation, and after that just take common t and also I, separate the two things. Okay, and after that just what is the formula of e to the power it plus e to the power minus it divided by 2, and also you can say e to the power it minus e to the power minus it divided by 2. Okay, this is the formula of sin it and also cos t. Okay, এটা আমরা শিখেছিলাম হাইপারবোলিক ফাংশনের সময় কিছু ফর্মুলা. So these are those things where we can also say, okay, there will be a minus term, so minus sign is here, just common with minus sign, and also you can get these things. Okay, and after that you can say minus 2 pi I, also this can be 2t cos t divided by 4, and also here you can say 2I by 4 sine, also okay, 2I sine t. So this is our formula, which means e to the power it plus e to the power minus it means 2 cos t, and also e to the power it minus e to the power minus it, so 2I sine t. Okay, this is the formula. After that, just simplify this thing. You can get your required result, which is minus 2 pi I, and here you can say this is our cos t. Just to is remove from those two things, and also here you can say, okay, there is also minus, because the formula is for minus sign, you have to let it. Okay, minus 2I sine t. Sorry for this here. Here e to the power it minus e to the power minus it minus the formula of this thing is minus 2I sine t. Okay, and after that you can say which is I square sine t. Okay, so from here that means here will be plus, sorry, 2I sine t. I said I just write it down here, e to the power it plus e to the power minus it divided by 2 cos t, and also e to the power it minus e to the power minus it divided by 2 sine t. I sine t. So I sine t. So here this is plus, not minus. So this is our plus, and from here you can say phi I, here t cos t, and also minus sin t, and after that just um, take this minus, multiply this minus sign here. You can say this is sin t minus t cos t, which is proved or showed. Okay. So this is the Cauchy residues problem. Okay. Do you get it, everyone? Do you have any problems in here? All of you, please tell me. So what we have done, just find out. If I say that just show that this function equals to this, and where C is the circle, and also I give the condition where modulus of this equals to something, and also t greater than 0. You can solve these things in by using this Cauchy residues theorem. Okay, so all of you know about the Cauchy residues theorem, where closed integration f z dz equals to 2 pi I into sum of the residues. Okay, so at first you have to find out the residues of your given function, and from here there you can also if it is simple pole, you have to use the simple pole formula for residues, and also if it is double pole or higher pole, you have to use derivative formula for residues. And after that, just sum those things, and also the apply the Cauchy residues formula. You can get your required result. Okay, so that's all for today. Next class, we will also discuss about Lorentz extension and also some maths of Lorentz extension. Okay, so everyone, do you give your attendance? সবাইকে attendance দিয়েছো?
Yes, sir.
ওকে, থ্যাংক ইউ। তো তোমাদের তো আর কোনো প্রবলেম নেই আজকে ম্যাথটাতে? কোনো প্রবলেম আছে কারো? Do you have any problems? Okay, that means no problem. Okay, so thank you everyone.